All right. So the next thing we have to learn is a little niche calculations. Very, very simple once you know how to do it. So some questions you might see will come like this. So they're going to say, well, here we see. Given that sine of theta is 7/12. Calculate the exact value of cosine of theta if theta is obtuse. What's your thoughts on this question?
I've seen the obtuse thing there, so I kind of hit in. Well, I know what obtuse angles are. I think it's what greater than 90 degrees. So I think it's something to do with the quadrants.
All right, go ahead.
And it's something to do with double angular formulae.
No.
No?
No. The quadrants part is correct, very correct. It has something to do with the quadrants. Now I want you to think about this here, and I tell all my students this. Think about this question initially from a mathematics perspective. Focus on the first piece. Sine theta is 7/12. Think of it as a maths student, not an art math student. When you see sine theta is 7/12, what are you thinking of? When you see sine theta, what are you thinking of?
A triangle.
What kind of triangle?
A right angle triangle.
Let me start there. So as soon as I see sine theta, that should be the first thing that comes to mind. A right-angled triangle. Where this fella here is theta. Yeah? Sine of theta is opposite over hypotenuse. Opposite over hypotenuse. Yeah? Perfect. I can use Pythagoras' theorem to figure out what the adjacent is. Yeah? We have the hypotenuse squared is the opposite squared plus the adjacent squared. 12 squared is 7 squared plus the adjacent squared. Rearrange, I get 144 minus 49. And I'm doing it one time. 95. So 95 is equal to the adjacent squared. Root 95 is the adjacent. Yeah? Yep. Now, if you want to overdo it a little bit, and nothing is wrong with this, it's plus or minus the root of 95. And then it's a plus root of 95 since lengths are positive. Yeah? But this is not the triangle. This is not the triangle for what we want. Theta is obtuse, which means theta is in the second quadrant. Yeah?
Yeah.
We already proved the whole quadrants business already. I could figure out what cosine of theta is. Cosine of theta is adjacent over hypotenuse, which is root 95 over 12. Yeah? But theta is obtuse. Theta lies in the second quadrant. Cosine is negative in the second quadrant. And that's it. I expressed cosine theta exactly. Cosine theta is negative 95 on 12. Now we can prove it. If sine theta is 7/12, I've seen students do this already. They're going to say, well, all right, cool. Theta is sine inverse of 7/12. Okay, that. Irrational. I'll go store it in E. Yeah, store it in E. So I have theta in the bag. If I calculate what cosine of theta is, I'm going to get negative something. Shucks. Cosine of theta. Sorry, I put cosine inverse of theta. Did I store it properly? Let me do it over. Sine inverse of 7 over 12 is that, and I'm storing that in A. Oh, theta is obtuse, so that is my principal value for theta. Yeah, theta
Yeah.
also lies in the second quadrant, which is 180 minus
Minus
my principal value,
value.
right? 180 take away my principal value, I get 144. I'm storing that in B, right? So cosine of B will give me a negative answer. Yeah. I wonder if this number is negative root 95 on 12. I wonder. If I take away negative root 95 on 12, I'm adding root 95 on 12. Tell me if you've seen that.
Mhm.
If I have, let me call this angle, I get this answer, I get on my calculator, C, take away negative root 95 on 12, I get C plus root 95 on 12. So if I add, open bracket, root 95 on 12, I should get 0. Jesus Christ. No, this calculator does do this from time to time. No idea why. All the versions of the calculator does it, but I 0. All right, I 0. Cool. That is indeed 0. Because if I go back up, cosine of the answer is, it was cosine of B, and this root 95 on 12, I'll store this in C. Root 95 divided by 12 is the same thing. Yeah. 812232 812232 Yeah, I typed in root 95 on 12. I didn't type in negative root 95 on 12. All right, they are the same number. I don't know why the calculator does that. I have no idea why. All right, so they are the same number. And by extension, in this example, I could also say, what is tan theta? I can create any question I want. I could say theta is reflex. If theta is reflex, it will be in reflex angle is
More than
180, less than 270.
Yeah.
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 It will be in quadrant 3. Yeah. I can say if theta is between 270 and 360 degrees, it could be in quadrant 4. All right. And I could, again, I can say, well, what is sine, what is cosine, what is tan of the same angle? Now, if students go on to the whole concept of calculating what theta is, there's no way I can figure out that theta is negative root 95 on 12. I will get a decimal equivalent to it. Some calculators will give it to you as a fraction, right? And I'll say that's the advantage of some of the calculators over this one that I use. It will give you theta, which is sine inverse of 7 on 12, as a fraction. All right. If you get theta as a fraction, brother man, you could figure out what cosine of theta is. It will also give you cosine of theta as a fraction. All right. All right. So next one here. I actually have one from one of my exams that I gave my students. Right? Where is it? It would have been after Trigs. So where did I do Trigs? I do Trigs here, I do Trigs here. So would this have been it? Ah, boy. Yes, it is. Right? If tan theta is root 7 on 21, I'll bring this across. I'll change the values because, I mean, we ain't do nothing with respect to radians as yet, but I'll change the question. -90 minus theta and 90 minus theta. All right, very, very nice question, very interesting question. And your boy make it up. So I'll leave that for you to do. And in the next part, we will do the solution and move on to our next part of Trigs.